Hey guys, it's 10 now, so I guess I'll get started shortly. So thank you very much for coming along, and thank you to the organisers for inviting me here. It's awesome to be here. It's the first conference I've ever been to where I've had to get on a plane to get to, so that's, for me anyway, that was really exciting. So I'm here today to talk a bit about JavaScript modules, and in particular how we deal with organising applications using modules as the applications we're building using JavaScript get bigger and bigger, more and more complex. A bit about me, my name is Jack Franklin, I work in London. That's me on Twitter, and also JavaScript Playground is a blog where I write a bunch of stuff around JavaScript, if you're interested. The company I work for is called GoCardless. We're an online payments provider, and we are hiring if anyone fancies a job writing Ruby or JavaScript in London. So the problem that we have with JavaScript, I know some people would say there are many problems with JavaScript, but the main problem we have is a lack of system for dealing with modules and building these complicated applications full of many different components, and how to wire them all together, how to define which modules depend on other modules, and how your application's graph of dependencies is built. And JavaScript was never built for this. When it was built originally, it was never envisaged that we do such complicated things that we are doing. And in particular, the problem comes when trying to manage dependencies. You have component A, which relies on component B being loaded into the page. How to ensure that that has happened? When you want to deploy your application to production, how do you ensure that when you've minified your JavaScript into one file, that component B has been minified above component A, so it's loaded in at the right stage? And that's quite tricky. There's no support for it yet in JavaScript. But thankfully, some people way cleverer than me have come up with a few solutions that I want to talk about first. So the first one is the asynchronous module definition, or AMD for short, which primarily exists through a library called RequireJS. Has anyone heard or used RequireJS? Wow, quite a lot of people, that's good. So RequireJS follows the AMD spec for defining and loading in modules. So just to show you an example, at the top I have the define is one file and the require is another file. We wrap our modules in this defined syntax. We can specify, I don't know if you can see the red, just about. You can specify your dependencies. So this module at the top depends on jQuery. And what RequireJS does is when it sees that is it will go and asynchronously load jQuery and return whatever it gives you back into the function. So it passes in the result of loading jQuery into the function as its first argument. We then return this object, which is defined as the module's public API. It's what the module exposes to all your other components. Then what we can do is require the file in a different module. Again, whatever that file exports is returned to us with that f argument. It's passed into the function. And then I can use the method as you can see there. This is quite nice, it works. It's a bit of an odd syntax to get your head around at first. It can take a bit of time to get used to, but generally it's quite a nice system. There are some kind of pros and cons to this. One of the really nice things about RequireJS is there's no dev build step. You don't have to run grunt something or gulp or whatever it is every single time you change a file like you do with other systems we'll see in a bit. It also provides a build tool for production, so you can minify this down dynamically into one JavaScript file. It's called R.js. However, there's a very, very specific syntax that I don't think is really transferable to anywhere else. And also it's asynchronous, which can be a bit weird to get your head around and sometimes can cause you problems. The fact that your dependencies are loaded in asynchronously can now and then become a real problem. So that's one of the most popular solutions. I've used RequireJS a lot. It's very popular. It's really nice. It works really well. There's also one called Browserify. How many people have heard of or used Browserify? Not quite as many. That's interesting. So Browserify aims to take this. So we have Node.js, which is JavaScript on the server. What Node.js also gave us was NPM, the Node package manager. And this is a really great system for publishing modules and installing dependencies. And Browserify aims to let us use NPM in the browser. So what it does is it takes the same module syntax Node.js has, which is a specification called CommonJS. So you write your code just as if you're writing it for Node. So you can see here we do the var $equals require jQuery. That goes and loads in jQuery. We then use this module.export syntax, which defines that the module should export an object. And here it's exporting the object with that one red function. Down below, we can just require the module and define it and set it to our app variable. And then we can just call app.read. So this is exactly what you'd write if this was a Node application, except you probably wouldn't be writing jQuery in your backend. But what Browserify does is it then runs this through a build step to effectively compile it, if you like, into a minified JavaScript file that can be used in the browser. So it effectively makes the requires work in the browser, which they wouldn't do by default. If you gave this to a browser right now, it would blow up. There are some pros and cons to this too. The most obvious con to me is that there's now a build step required every single time you change a file in development. This is obviously fairly easily automated with something like grunt or gulp, even a make file that just watches for file changes and runs a specific command. But it's still a bit of a pain. You can use that same tool, though, to minify it altogether for production, so that's really nice. The syntax is a little more transferable. I think CommonJS is easier to pick up than RequireJS. There's less to it. You've really just got those require calls and then module.exports. And it's all synchronous as well, which is really nice to work with. The fact that you can just do var $equals require jQuery and it will just kind of work is really nice. So if I had to pick one of these two, I personally would always go with Browserify, but some people prefer RequireJS, and that's fine too. There is, of course, a third way, which kind of isn't really a way at all, and it's just using script tags. This is probably how we all got started with JavaScript, how we all dealt with dependencies prior to finding one of the libraries out there. But really, this is just full of problems, and I would certainly not encourage you to do this ever. If we have a module.js which defines that red function, we have app.js which calls it, and then we have those script tags in our HTML file, there's a bunch of things going on here that just are already confusing with this very small example, and will only get a lot more confusing once you've got a bigger project. You can see we create this var red function, but we do it globally. This means that red is on the global scope. If you imagine having a bunch of modules and all of them exporting everything onto the global scope, not only is that incredibly confusing, it also leaves a lot of potential for modules to override other modules. In app.js, and then also we've got this dollar here. And in the context of if you're just looking at module.js, it's not clear what that dollar is. You'd probably guess it was jQuery, but it's also not clear where it comes from. And nothing in this file defines that module.js depends on jQuery being available. Similarly, in app.js, we just call this red function, but we've no idea where red comes from. And also, every single time you add a new JavaScript file, you have to add a corresponding script tag. Not only that, you have to make sure they're loaded in the right order. This is trivial when you've got 3 script tags, but significantly less so if you've got 10, 15, and so on. So this is just a dreadful idea. There's no real dev build step, except you have to have script tags and add one every single time, and then maintain the order. Building this for production is kind of pain because you have to edit the HTML to insert a script tag to a new minified version. There's no dependency management. You don't know if it's asynchronous or synchronous. You can't deal with it. There's no dependency management, and it's just a dreadful solution. So RequireJS and Browserify are really nice solutions given what we have. Script tags are certainly not. But a bunch of people thought about this and thought we could do better. There is a new version of JavaScript coming, and I'm glad to say that we have done better, where we is not me at all. It's a bunch of people a lot cleverer. The latest specification for JavaScript is called ECMAScript 6. I think the spec is to be fully confirmed in January, but the module syntax, the bit I'm going to show today, pretty much has been confirmed. So ES6 brings along a new module system entirely written from the ground up. It will eventually be supported in browsers natively. And this really is going to solve a lot of the problems right now. And I'm going to do a demo at the end where I show you how you can do this stuff today. But just to be clear, this stuff isn't in browsers. That doesn't mean you can't use it. We've been using it at work on a project for a few months, and it's worked absolutely perfectly. We haven't had any problems, and it's very straightforward to set up. So yes, this stuff doesn't work in browser, But there are a lot of tools which I'll demo that let you use it today that are very easy and trivial and straightforward to use, and I'd really recommend you doing so. So this is an example of the new module syntax. We've got two files again. Notice the top line imports $ from jQuery. So this grabs whatever the jQuery module is exporting and assigns it to the $ variable. You then export variables as you want to, just by putting the export keyword in front of them. Or you could define the variable red and lower down have a line that said export red. At app.js, we can import everything this module exports by doing import start as app. That lets us get an app.red to call that red variable that was exported. Often, though, if you're working with a module that exports a bunch of things, you don't actually need all those things. You only need maybe one or two of the functions it gives you. And there's a syntax for doing that as well, which looks somewhat like this. So what you do now is you wrap what the name of the function you want in curly braces, and you get that function directly. So here I've imported just the red function from the module rather than importing everything the module exports. Typically, though, it's good design for a module to export one thing, whether it's one object or more commonly, perhaps one function. Libraries like jQuery typically export just one function, the $ function. And ES6 Modules has a syntax for what's called a default export. What this means is that this module is only going to export one thing. And it's a regular export. It's called the default export, which is a special export that gives it some different kind of properties. So here I've changed module.js to export just this function. Notice that this function isn't named now. It doesn't have to be named. And then in app.js, what I do is I just do import red from module. It's important to note that where I've got import red, I could name red there whatever I want to name, because the function I haven't actually named. I'm just saying this module exports this function, and it's up to you to name it whatever you'd like to when you import it. So this is kind of the way people want you to write modules. Default exports have kind of been encouraged by the people writing and defining the syntax. Personally, I'm not so sure. I quite like the idea of doing named exports. I think it's a bit more clear. But kind of your mileage may vary. See which one you prefer. Something really interesting about the module system in JavaScript, or the new one, is that it's going to be entirely statically based. What this means is currently in, say, Node.js, the module system there, the code has to be run and executed and evaluated so it knows what the code is importing or exporting. With this system, that doesn't have to happen. It can all be done statically without the need to evaluate all the modules. This brings us a lot of benefits, which I don't have time to go into in too much detail, as I want to get to some actual code. That means you don't have to run the entire code to know what a module is importing or exporting. This can give you a bunch of performance benefits. It also could potentially help IDEs, because at any point you know exactly which variables are available within the scope of a module, because you know which modules exist and what they're importing and exporting. Because you don't have to evaluate the files as well, it means you can deal with circular dependencies just fine. If you've got module A and a module B that depend on each other, in say CommonJS, that wouldn't work. Because it has to evaluate the file, it will just go on forever and it will blow up. But that stuff is supported, although you shouldn't be doing it, and will work with the new system. It also means it's ready for types when /if types come along to JavaScript. I think they will come along to JavaScript at some point, but we're way off that yet. And because it can tell all this stuff without having to execute things, once it does execute things, it can figure out if a module is exporting asynchronously or synchronously and just kind of deal with it. So all this stuff kind of is just going to work. Because it's all static, it knows what a module is exporting, and if it sees that the thing it's exporting is asynchronous, it can load in that module, wait for the asynchronous process to return, and then it can evaluate the body of the module that depends on it. So this is really nice. And effectively, it just kind of works, which isn't something us JavaScript developers get to say that often. But in practice as well, it's really nice. A big part of ES6, the new version of JavaScript, was making it nicer and easier to build more complex applications, and this certainly helps a lot towards that. There's also, though, like a programmatic API if you'd like to actually do this stuff a bit more programmatically. So we'll get a bunch of new functions on the system object. There's system.import. I think there's even system.export. There's a few of them. And this will return a promise. And when this promise resolves, you get the modules export, and you can call the method on it. This isn't that exciting. You would never do this. But there's potential to do a lot here, because what we're also going to be provided with are these hooks. I haven't got an example of this because the spec for this isn't fully confirmed yet. But what this is going to be is it's going to be hooks that will be inserted at different stages of the module being loaded in. And you can attach arbitrary functions to those hooks. This means potentially, say, whenever you load it in a module, you might run it through JSHint or JSLint first. You can kind of automate that stuff and make it just happen automatically for you. And obviously turn it off when you push to production. The best reference for this, and I'll put the slides online and tweet them with the hashtag, so don't worry about writing the URL down, is the Tuality blog, which is a really good blog generally. This post in particular is pretty much the reference for ES6 modules. I ran everything I picked by it to make sure it was okay. This is a mega blog post on the full ES6 module spec and what it will look like. It goes into a lot of detail that I haven't got time to go into today. So if you are interested, I'd really recommend giving that a read at some point. So that's all great, and this is going to be really cool when it lands in browsers. I've no idea where it will land in browsers. That's kind of a bit of a guess. As I said, it's possible to do this stuff right now. Thankfully, there are people even more impatient than me who want to play with this stuff a lot earlier than me, who have built really nice tools that let us do it. And let us do it surprisingly well with very little problems. The first is something called System.js, and it's by a guy called Guy Bedford, who actually has written most of the stuff I'm going to talk about from here on in. And this is a universal module loader. So what this means is it can take modules written and using the CommonJS or the Node.js syntax, the RequireJS syntax, and also the ES6 syntax, and load them all in for you. And it does this using a combination of three things. So it uses System.js, that's it, that's the library. Then for the ES6 stuff, it uses the ES6 module loader, which is another project by Guy Bedford, the same person. This supports loading in ES6 modules. It basically provides polyfills for system.import and all those methods. And then whenever it detects a file as ES6, it uses this project called Traceur, which is by Google. And this is a compiler that can take ES6 JavaScript and convert it into ES5 JavaScript. So basically, it can take JavaScript that wouldn't work in a browser now and convert it down into JavaScript that will work in a browser now. A combination of these three things can give you effectively full ES6 module support. And it's really straightforward to set up as well. So what you do is you first load in the System.js file, which you just download from GitHub. You also have to download Traceur and the ES6 module loader, but you don't have to include them. Then what we do is we use this system.import to import our main app file. And you can see in app.js I've just got an alert for hello world. I'm not going to show you this bit, but if I were to load this file up in a browser, I would get alert hello world. This all kind of just works. What System.js does is it loads in app.js, and it will load in Traceur and the ES6 module loader only if it needs to. So if it detects you've given it some ES6, it will then load in Traceur and the ES6 module loader to do that stuff for you. There are ways, of course, you can bundle this all together for production, so you don't have all those extra HTTP requests there. One real gotcha that tripped me up is, it depends how familiar you are with JavaScript promises, but JavaScript promises by default swallow errors. So if something goes wrong with this system.import call, if there's a syntax error or just some random error, by default, nothing will get logged to the console because the promise effectively captures and swallows the error. This is, useless. But thankfully, we can kind of get around it. So if you are going to go and play with this stuff, you need to do system.import app and then give it a call to catch. Now, catch is what's called if a promise rejects. So if something went wrong and a promise rejects itself, whatever function you give to catch will be called. And here I'm just giving it console.error, but we have to bind it to the console because JavaScript. But this makes sure any errors actually get logged to the console. And having been there, trust me, this will save you a lot of pain down the road. And notice as well here, just as a second example, I've changed the bottom line to just have a paragraph with the text hello world in. So I've got my app.js, and what I've done is I've created a new file called red.js. So this uses the ES6 syntax. It imports $ from jQuery. We export a default function, which takes that paragraph and changes the color of the text to red as that, and we export the default function. My app.js then imports $ from jQuery. It imports the red function from the red module. Then when the DOM is ready, we call the red method. This is all using System.js and that system.import app. And if you load this up, we do get hello world in red text. That's just to kind of prove this stuff all works. Interestingly, what System.js does is it makes these requests via XHR, via HTTP requests. And if you kind of load up the Chrome DevTools, when you look at this, you can see it's making those requests, Traceur and a few other, and red.js, jQuery.js too. And you can see those were all initiated by the ES6 module loader. So that's the thing that basically is doing most of the work. Cool, so that's really nice. And I would recommend you play with this. We've written an app using System.js. It works really well. The guy who wrote System.js, Guy Bedford, also wrote something else called JSPM.io. And it's that I'm going to attempt a live demo. The Wi-Fi was working 20 minutes ago. We'll see if it's still working. If not, I'll ditch it. But this is really cool. And if I were to start a project tomorrow, this JSPM, the JavaScript package manager, this is what I'd use to build an app. And I'd like to just give you a very, very, very brief overview, Wi-Fi dependent of it. Let's mute that. Cool. Okay, so hopefully the Wi-Fi is holding up, and let's just mirror it. I think that's going to be easier. Oh, wow. Cool. Can people read that at the back? Is that good? Yes, thank you. Okay, so let me just take you. So if you head to jspm.io, you can find out more. JSPM effectively sits on top of System.js, and what it does is it's a package manager that lets you pull in modules from the Node package manager, download anything from GitHub, load it into your page, and it will all just kind of do the work behind the scenes to make it all work in the browser for you. So I've done a small amount of preparation here just to save boring typing. I've just got this one HTML file. It's loading in System.js, which I haven't actually downloaded yet. It's loading in this config.js, which again is a file that hasn't been created yet. JSPM is going to create these for me in a minute. And then I've got that system.import./app. ./app doesn't exist. There is only this one HTML file. I've done nothing else. So I'm going to come out of Vim. I saw some Emacs users yesterday, so it's good to get some Vim on the screen. And I'm just going to run JSPM install. So JSPM you install through the Node package manager. I haven't really got time to do all that. So you install it. It's going to ask me a bunch of questions. These are all documented. And what it's going to do now is it's going to go and download a bunch of stuff, including the ES6 module loader, Traceur, System.js, and a few other things. It's also going to create that config.js file. So now if we kind of look in this directory, we have this config. We have JSPM packages, which contain System.js, ES6 module loader, Traceur, and a few other bits and pieces as well. So if I now go and create this app.js file, and I just do alert hello world, I have this running on a server locally. Hopefully, okay, we get hello world. That's panic 1 over. The first demo has worked. Phew. Okay, so we can alert hello world, and we can load in this file using System.js. That's not particularly exciting. Say I was starting a project, and I needed, who's heard of Lodash? Who's heard of underscore? A few more people. So Lodash is basically like underscore, but a little bit more performant and a bit nicer. So say I decide that I need Lodash. And I know that Lodash is published on NPM. And I know that JSPM lets me use NPM modules in the browser because it's magic. So I can take JSPM install. I'm going to say npm :Lodash. This is going to go and install Lodash from NPM. There we go. That's the Wi-Fi is really doing quite well. And we can see if we now look at config.js, this is what System.js is creating and is editing for me. You can see it set up a whole bunch of maps and kind of versions of libraries that I'm depending on. If I go back to app.js, I'm now going to say, right, I want to import underscore from npm:/lodash. And we'll change the alert, and you can do underscore.version to see what version of Lodash you're using. So we're now using ES6 modules, but note that we're using ES6 module loader, which doesn't work in the browser, to load in npm's version of Lodash, which also isn't supposed to work in the browser, but using System.js and all this other stuff to kind of make it work. And then we get, I don't know if you can see that, but it does say 2.4.1, which is the latest version of Lodash. Say then we wanted jQuery too. So I could install this from a number of different sources, but JSPM actually has a small registry for all the most popular modules. So I can just type JSPM install jQuery. This is actually going to go and download jQuery from GitHub, from the, there you go, GitHub components/jQuery. So it's just grabbed that repository down for me and done a bunch of config to set it all up. Now let's import $ from just jQuery. The reason I can type just jQuery is because I installed just jQuery, and if you look in config.js, System.js maintains a bunch of maps. So basically down here on this line, you can see that jQuery is mapped to GitHub:/components/jQuery and then the specific version. So now let's write some jQuery. Okay, we don't need that one anymore. So this really is the moment of truth. Look at that, there we go. So what we've done there is we've pulled in jQuery and we've imported it using this new syntax, which doesn't even work in the browser yet, using JSPM, which really is a pretty awesome solution. It's jspm.io. I'll tweet a link. I'll put some more URLs in the slide deck before I publish it as well, so you'll find links to everything I've mentioned. Guy Bedford goes through it in a lot more detail in the talk that's online. I'd really recommend giving that a watch if you plan to use it. But we're actually planning at work to move our rather large Angular app over from using just System.js to using JSPM, because we really like it. I haven't got time to demo it, but JSPM also includes a bundle command, so you can take your app and bundle it into one file to push to production. So it'll all kind of, it supports kind of bundling and minifying it all up into one when you push it live too. Okay, so now let's try and go back to this. Okay, so I've done my demo. These are my backup slides, so we can ditch the backup slides. This is the best solution right now. As I said, I'd really recommend if you would start a big JavaScript project anytime soon, JSPM would be the way to go. It has the bundle command. You can give it your kind of main app.js file. It will there go from there, figure out all the dependencies, minify it all into one for you. Once you've done that, you just have to chuck, it will kind of spit out build.js. You put that into an HTML file along with System.js and the config, and then it will all work. When it then does system.import app, it's not actually going to make an HTTP request because app.js has kind of already been registered through build.js. And of course, you can minify this all into one too. So you can use this stuff fairly straightforwardly in production. It just works, and even the demo just worked. That shows you how good it is. So that's jspm.io. The person who built all of that, I've got nothing to do with it other than I really like using it, is at Guy Bedford. I really would recommend following him. He's got a few really good blog posts. I think it's guybedford.com, but you can find it from Twitter, that go into a lot more detail on JSPM and how it all works. So basically, the TLDR of the talk is that ES6 is coming. The tooling is there right now. You can use this today. The tooling and the kind of ecosystem of how we use this stuff is only going to improve over time. And of course, eventually, one day, there will come a time where you can ditch this stuff. And because you've been using ES6, it will all just work and continue to work in the browser once browsers support it. So I'd really encourage you, this is the way forward. It works, and it's only going to be even more cool. So that's all I've got time for. As I said, that's me on Twitter. I'll tweet a link to the slides. I'll use the hashtag PolyConf as well, so you can dig it out. URLs are in there. I'll add all the references and things too. I guess maybe I have time for questions. I have time for one question. Or I am around for the entire day, so feel free to come and grab me at any point. I can see barely anything from up here, so.
Hello.
Hey.
All right. So I have a question about loading the modules.
Yeah.
Have you seen, are those loaded asynchronously as well, or is this kind of blocking XHR?
They're loaded asynchronously.
So basically, when you have the import, the compiled code, after all, results in some kind of asynchronous, or I don't know, promises or something, which basically wait for the file to load, right?
Yeah, pretty much exactly that. Yeah. So it's not blocking at all. Maybe one more. There was one right at the back I saw, just to make you guys run a bit.
So I think there's a trend and people start to build module systems that bundle not only JS modules and JS files, but also things like CSS. What do you think about that?
I've never done it before, but it seems like quite a smart idea. So we use a project called Asset Graph. I'll try and find it. Hang on, it's going to be easier, isn't it? So Asset Graph is a really a nice. There we go. What it basically does is you give it an HTML file, and it effectively reads that and builds a massive graph of dependencies for your application. And those aren't just JavaScript dependencies; those are CSS, fonts, images, etc., etc. And it can kind of bundle those all up into one big file and spit it all back at you. We kind of use something a bit similar at work. We don't quite bundle like all the CSS inline. But I can kind of see why it would make sense to do that, but I haven't done it yet. But it certainly seems cool. Asset Graph is also a really, really nice project that I could do like 10 talks on. So I'd really recommend checking that out. That kind of is more towards that way of thinking. Cool. Well, yeah, I'm around for the rest of the day and hopefully at the party this evening, so feel free to come and chat to me. And thank you for listening.